So let's take a look at this question here. We have that Tom has 3 types of toys: trucks, cars, and jets. Then we're given some information, and the information is a bit tricky to read at first. So we just got to try and set this problem up in a way that we can easily understand it. The first thing I would identify is that there are 3 types of toys: trucks, cars, and jets. So I'm going to give them labels. So I'm going to let T stand for trucks, I'll let C stand for cars, and I'll let J stand for jets. So these are the toys that Tom has. So all of his toys are consisting of trucks, cars, and jets, because those are the only 3 types of toys that he has. I can actually, off the bat, go ahead and say, well, all of Tom's toys, so all of Tom's toys is equal to all the number of trucks he has, plus all the number of cars he has, plus all the number of jets he has. So I'm just playing around with the information I've been given, and I see I can write that. All of Tom's toys are equal to the number of trucks he has, the number of cars he has, and the number of jets he has. I now see that the first piece of information, well, the second piece of information really, is all of his toys except 21 are jets. So all of his toys except 21. So except 21 in this case, the way we read it is all of his toys, if you count all of them, 21 of them are not jets. So that's how we read it. All of his toys except 21 of them are jets. So how can I write this out? Well, if I know all of Tom's toys is given by that, right, the total number of toys he has is just adding up all the types of toys, then I can say, well, if all of his toys except 21 are jets, then that means the cars and the trucks, because those are not jets, the cars and the trucks, those must add up to 21. Okay, so all of his toys except 21 of them are jets. So when you add up the number of cars and trucks you have, okay, you get 21 of them, because those are the 21s that are not jets. Okay, I hope that makes sense. Reading the next piece of information, all of his toys except 23 are trucks, so all of his cars plus all of his jets give you 23. Lastly, all of his toys except 26 are cars, so all of his trucks plus all of his jets, right, because you're not looking at cars, gives you 26. So now you have a set of simultaneous equations. And the question is asking us for the number of jets. So we're going to go use these simultaneous equations to try to get jets by itself. If I look at the first 2 equations, so let's call it equation 1, equation 2, equation 3. Right, because equation 3 and equation 2 have jets, those are the ones I'm most likely going to have to work with. So I'll work with equation 1 first, and equation 2, and I see that if I subtract equation 2 from equation 1, I get, well, C minus C is going to give me 0. We're going to have J minus T on the left-hand side, and 23 minus 21, which gives us 2 on the right-hand side. And then equation 3 tells us that we have the number of trucks plus the number of jets equals 26. Now, I can go and add these 2 equations, because that'll get rid of the truck and the minus truck. I'll get J plus J, which is 2 times J, and 26 plus 2 on the right-hand side, which is 28. Right, and therefore, dividing both sides by 2, I get the number of jets to be